Hello, my name is Tom. I am going to talk today about how an engine works, and we're going to look at the four strokes of a four-stroke engine. I teach technical English to students who study technical industrial production at the Schoolship Gann in Stavanger, Norway. So we're going to look at a little bit of Norwegian. Now notice in Norwegian you say fire takksmåte. And in English we say four-stroke engine. So when we say engine, you're saying måte. And don't forget, when we say engine room in a ship, you say machine room. Now those three words have a big difference in English. An engine is any machine designed to convert energy, for example, thermal energy, into mechanical work, like a steam engine, petrol engine, right? A motor, for us, is a machine that converts electrical energy, for example, a start motor on an engine, and that transferring that electrical energy from the battery into mechanical energy starting the engine. Okay, so when we talk about machine also, I mean, there could be simple machines. So the words are different between our two languages, but just get them straight in English, that we're talking about an engine, an internal combustion engine. Now what we're going to do is watch this movie that we saw last time one more time, and then we're going to look at the words engine displacement, and we're also going to look at compression ratio after that. Here we go.
We're going to explore some technologies that Toyota uses to maximize engine performance and economy and reduce emissions. First, we'll review the basics of how an engine works and some basic engine terminology. An internal combustion engine needs air and fuel to function. The more efficiently an engine breathes, the more efficiently it will produce power. Now we'll look at the basic components of an engine. The main components of the engine are the engine block and cylinder head. The internal components of an engine include cylinders, the crankshaft, connecting rods, pistons, spark plugs, fuel injectors, intake and exhaust valves, camshafts, and a timing chain or belt. Power is produced in the engine by the four-stroke process. As the piston moves on its first downward stroke, the intake valve opens to allow a mixture of air and fuel to fill the combustion chamber. This is called the intake stroke. Next, the intake valve closes and the piston moves on an upward stroke that compresses the air-fuel mixture. The compression of the air-fuel mixture will make it combust with greater force than if it were uncompressed. This is called the compression stroke. Third, the spark plug ignites the air-fuel mixture, causing it to burn explosively, which forces the piston into another downward stroke. This is called the power stroke. The fourth stroke is the exhaust stroke. As the piston begins its second upward stroke, the exhaust valve opens and the burned air-fuel mixture is forced out of the combustion chamber through the exhaust valves. Two terms you may be asked to explain to customers are the engine's compression ratio and displacement. Compression ratio is the ratio between the total volume of a combustion chamber and cylinder when the piston is at the bottom of its stroke and when the piston is at the top of its stroke. In this example, the compression ratio is 10:1. Higher compression ratios produce more power but require higher octane fuel than engines with lower compression ratios. Engine displacement is how the internal size of an engine is described. It's measured as the cylinder bore times the length of the piston stroke. This is multiplied by the total number of cylinders and is usually expressed in liters or cubic centimeters. For example, a 2.4-liter four-cylinder engine has a total displacement when adding together all four cylinders of 2.4 liters. The number of valves that engines have varies. Older engines tend to have one intake and one exhaust valve. Some engines have 2 intake and 1 exhaust valve. Most high-performance engines use 2 intake and 2 exhaust valves. The opening and closing of the valves is performed by the camshaft. Some engines use 1 camshaft with rocker arms and/or push rods actuating all of the valves. If the camshaft is above the valves, it's called a single overhead camshaft or SOHC engine. When an engine uses a separate camshaft for the intake and exhaust valves mounted above the valves, this design is called double overhead camshafts or DOHC. All Toyota engines use double overhead camshafts. Most 4-cylinder engines, including all Toyota 4-cylinder engines, are an inline design. Engines with more than 4 cylinders typically have the cylinders arranged in a V configuration. All Toyota 6- and 8-cylinder engines are V-type engines.
Okay, so now we've got the basic parts of the engine that we went through last time. Let's just look at this compression ratio again. Okay, you say kompressionsforhold. Okay, but what exactly is this? Well, I'm not supposed to teach this so much in English, but let's just look at the words in English. Compression ratio of an internal combustion engine, or even an external combustion engine, if you remember, that's a steam engine. It's a value that represents the ratio of the volume of its combustion chamber from its largest capacity, when the stroke is all the way bottom dead center, all the way to its smallest capacity, which would be top dead center. So you would see with the stroke of the piston all the way at the bottom, its largest capacity, and then comparing its capacity to the very, very top, at top dead center. What's saying TC here. It's the fundamental specification for many common combustion engines. Okay, so in a piston engine, the ratio between the volume of the cylinder and the combustion chamber when the piston is at the bottom of its stroke, and the volume of the combustion chamber when the piston is at the top of its stroke. Okay, so for example, a cylinder and its combustion chamber with the piston at the bottom stroke may be 1,000 cc's of air. 900 cc in the cylinder plus 100 cc in the combustion chamber. And when the piston has moved up to the top of its stroke inside the cylinder, the remaining volume inside the head may be reduced down to 100 cc. So the compression ratio is about 1,000 to 100 or 10 to 1. Okay, so a high compression ratio is desirable because it allows an engine to get more mechanical energy out of that air-fuel mixture due to its higher thermal efficiency. Complicated, I know. Let's go on to the next term. When you talk about an engine size, we usually say it's a 2.4 liter engine, 3.3. Well, what is that? Well, first, when you're looking at the size of the cylinder, we talk about the bore. So, for example, you have a Magnum 45 or a 303 shotgun. That's talking about the size of the actual cylinder of the barrel of the gun. So we call that in a gun or a cannon or a cylinder here in an engine the bore. Okay, so it's good to know that word. So let's say that you have a bore of 2 inches, right? The diameter of your cylinder, the bore, is 2 inches. In centimeters, that would be a 5.08, okay? And then how far the piston goes from bottom dead center to top dead center is called the stroke, the distance that the piston actually goes up and down on its strokes, okay? So let's just say, for example, that's 4 inches, okay? And in centimeters, 10.16. So you got to do a little bit math. Here's the formula for it to find the displacement, okay? So we take the bore, 5.08 centimeters, and we have that to the second power, right? Times pi, and pi, you know, is 3.14, times the stroke, which is 10.16 centimeters. And that gives us 8.23. We can just round it up to 830 cubic centimeters. Now we got to times that. We have 4 cylinders, so we have to times that by 4. So that would give us a little over 3,000 cubic centimeters, or 3.3 liter engine. So then we talk about the size of how big the actual engine is. Engine displacement, you say slag volume. So why should you even care about this at all, right? A car manufacturer says that you've got a 3.3 liter engine. So if you were to turn the crankshaft through 2 complete revolutions, the 4 pistons would inhale a total of 3.3 liters of air. Well, there's a sticker on the back of many American cars telling you about this engine's displacement. And the displacement of an engine gives you an estimate of the maximum power the engine can produce. When you mix gasoline with air and burn it in an engine, you can only mix in so much gasoline. The amount of gasoline is limited by the amount of oxygen. If you mixed in more gasoline, it would not matter because there would be no more oxygen in the cylinder to burn it. The ratio is about 15 to 1. That's 15 parts air to 1 part gasoline by weight. The displacement tells you the maximum amount of gasoline the engine can burn. And this controls the maximum power the engine can produce. Okay, great. So now let's get into the strokes, the 4 strokes of a 4-stroke engine, right? It was explained exceptionally well in the movie, but I just want to go through it again with you. The 4-stroke engine was first introduced by Nicholas Otto, we said last time, end of the 19th century, and so it's known as the Otto cycle. The commonly used term, however, is 4-stroke engine, and it takes its name from the 4 strokes the piston needs to complete the process of converting fuel energy into work. And the 4 strokes are known as the suction, or the intake or induction stroke, and the compression stroke, the power stroke, and the exhaust stroke. So you're going to have to learn what these are in English. I'm sure you know what they are in Norwegian, but yep, you need to know these for English. Okay, so let's look at the first stroke, the suction stroke, intake stroke. During this stroke, the crankshaft rotates clockwise and the piston moves down the cylinder, and it sucks in air. The inlet valve is open and the fresh air charge is sucked in, or we say drawn, into the cylinder. Okay, and now the compression stroke, remember this is where you get the big bang. Is it the air and the fuel is compressed into a small little area. The inlet valve closes and the charge of air is compressed by the piston moving up. The pressure and temperature increase, and the time the piston approaches the top of the cylinder, known as top dead center, TDC, the pressure is over 100 bar. Now in diesel engines there is no spark plug. The compression itself ignites the explosion, the combustion. But here at the top of the compression stroke, the spark plug ignites. Remember that word we have, to ignite. And then you get the power stroke. So just before the top dead center, fuel is injected into the cylinder by a fuel injector. Remember we said dieselhålle, and that atomizes. It puts the fuel into small little droplets mixed with air so that it burns so much more efficiently. So they heat up quickly and then they start to burn, and the expanding gases, kaboom, force the piston down the cylinder, and this turns the crankshaft, the workhorse of the engine. During this stroke, this is where you get the work out of the engine. And then the exhaust stroke. After that big bang, you've got exhaust that needs to get out. So the piston, after it approaches bottom, it goes at bottom dead center. We call it BDC. Then it starts to go back up, and the exhaust valve opens, and the hot gases are expelled, kicked out of the cylinder. And there you have it. That's how it works, basically. You have the intake, the compression stroke, the power stroke, and the exhaust stroke. Excellent. Okay, great. So let's just see it one more time. I've got a cool movie here to show you one more time without all the metal in the way, just seeing it.
Today, the internal combustion engine is used in motorcycles, automobiles, boats, trucks, aircraft, ships, heavy-duty machinery and power generators. A 4-stroke engine is an internal combustion engine in which the piston completes 4 separate strokes, intake, compression, power, and exhaust during 2 separate revolutions of the engine's crankshaft, and 1 single thermodynamic cycle. Let's take a look at the basic internal parts of a 4-stroke engine. Inside the engine block, there is a crankshaft. Piston rods are attached to crankshaft. Pistons are attached to the pistons rods. As the crankshaft turns, it causes the lifter to make each piston move up and down. At the top of the crankshaft there is a camshaft which is connected to the crankshaft by a timing belt. While the crankshaft is making the pistons move up and down, the camshaft is turning, making the valves to open and close.
Let's now take a look at how the combustion creates pistons motion.
First, intake stroke. The inlet valve is opened, and the fuel-air mixture is drawn in, as the piston travels down. Second, compression stroke. The inlet valve is closed, and the piston travels back up the cylinder, compressing the fuel-air mixture. Just before piston reaches the top of its compression stroke, a spark plug emits a spark, to combust the fuel-air mixture. Third, combustion stroke. The piston is now forced down by the pressure wave of the combustion, of the fuel-air mixture. The engine's power is derived from this cycle. Fourth, exhaust stroke. The exhaust valve is opened, and the piston travels back up, expelling the exhaust gases through the exhaust valve. At the top of the stroke the exhaust valve is closed. This process is repeated. What had been presented is the cycle of operation of one cylinder, of a four-stroke engine. Generally engines have two or more cylinders acting in concert with each other to produce the engine power.
So if you were really good here and following along, you notice he said piston rod, not connecting rod between the piston and the crankshaft. Yeah, and of course there's different words in a main big engine on a vessel. It's a diesel engine, you have a connecting rod and a piston rod, so there's a little different words, but we'll just stick with the main word connecting rod for our purposes. So what we're going to do now is go and do some of the words that we've learned here in English. I want you to write the Norwegian equivalent for these words. Okay, so I'm going to give you 3 minutes. You should know what these are in Norwegian, but we're just going to check and make sure. Let's take 3 minutes going, starting now.
Run, Forrest, run!
Alrighty then.
Yeah, that's a good one.
Yeah.
Oh, you betcha, yeah.
Yeah. You're all in good time.
Okay, great. So now let's see what you got. You should have used a dictionary or word finder on your computer. Four-stroke, I gave that one to you already. You say fire taks motor, but don't forget motor is very different in English than in Norwegian. Suction, the intake stroke. What do you say? Insugingstakt. Okay, compression stroke. What do you say in Norwegian? Komprimerings or kompressionstakt. Top dead center, do you have a word for that? Øvre dødpunkt. And then power stroke. What do you say for the power stroke? Antenningstakt or arbeidstakt. You can say that one. Atomize, when we're breaking the fuel up into small little droplets, we call that forstøvet or atomisert. I guess you could say that as well. Exhaust stroke, what do you have for that one? Utblåsingstak. And then bottom dead center, what do you have there? Nedre dødspunkt. Okay, so now in your workbooks, and if you are watching this online, I have a link for the workbook if you want to do this yourself, where you found this YouTube video, so you can just click on the link and download the workbook. So I want you to pick the right word here, okay? You get just 1 minute. Pick the right word you think that belongs and completes the sentence. Here we go.
You're crazy!
No, I'm not.
That's all, folks.
There you go, Porky Pig. Right, let's see what you got. Now, tiny fuel droplets heat up. That's the whole point of the fuel injector, to get a better efficient burn. So you get into tiny little fuel droplets so they heat up very quickly. The expanding gases force the piston down the cylinder. And now the four-stroke engine powers almost all cars and trucks today. The piston draws. We had that when it sucks in. We call it drawing. A fresh charge, load, a charge of vaporized from the fuel injector, vaporized, atomized fuel-air mixture. Engines convert. That's the whole point of an engine. They're converting the energy, the latent energy in the fuel, into work. And then the fuel injector draws fuel into the cylinder. You can have drawing, pulling, or pushing. Okay, great. Here we go. 2 minutes. What I'd like you to do is draw a line or connect these two words, the words on the left with the words on the right. 2 minutes. Here we go.
Come on, I ain't got all day.
I'll be back. You're traveling through another dimension. A dimension not only of sight and sound, but of mind. A journey into a wondrous land whose boundaries are that of imagination. That's the signpost up ahead. Your next stop, the Twilight Zone.
Oh, nice. I grew up with the Twilight Zone. Here we go. We're going to match these words. What did you get for convert? Convert is to change, right? We're changing thermal energy into mechanical work. Increase, rise. Drop, to fall. Temperature drops, temperature's falling. Complete, to finish. Squeeze, compress. So that's what we're doing, the compression stroke. We're squeezing that air and that fuel together. Drawn, remember that was to pull or to push. You can draw, push, or pull. Tiny, very, very small. Atomized, verstövet, vaporized. You can say as well. To turn around, rotate. We're talking about the rotating motion. And a charge, remember, that was a load of air. Okay, that's great. Thank you so much for following along. Bye bye for now. We'll see you next time.